All right, we are starting our fifth unit, which is trig identities and equations. Now, typically this can be a scary unit, one of the more challenging units. However, you do have something to your advantage in that normally in class we would be spending a lot of time going over the identities, talking about them, deriving them, and then you'd have to memorize them. Whereas you have the benefit, obviously it'd be better to be in class, but you have the benefit virtually right now where you'll be able to refer to all of the identities, which, speaking of that, please make sure before you start into the actual lesson after this that you have either printed off the formula sheet that I gave you that I posted on D2L before this lesson. If you don't have a printer, that's okay. Make sure you copy it all down. And a lot of the things that we reference for the rest of this unit are going to come off of that sheet. So you're not going to want to write anything else on that, so you can just always pull it out and refer to it. So our learning goals, we are going to identify equivalent trig relationships, which you've kind of already done. We just didn't call it that. We're going to start with a little warm up here, little brain activity, thinking activity from last unit, which you just wrote a test on, and hopefully it went well for you. What are four possible equations for the function shown? So, well, what's our equation of axis, right? This is what you would have done for last unit on your test. Our equation of axis, max plus min divided by 2, 0. So our C value is 0. So one possible, so I'll put that in here. There's our C value, which is y equals 0. And what's our period? How long does it take to complete one full cycle? Well, if I start here, okay, I go all the way around here, I get back to the start, 2 pi is my period. So the period equals 2 pi, which quite simply just means k is 1. We're starting it off really easy with this warm up. What's your amplitude? Well, your amplitude is the distance from your max or min to your equation of axis, which in this case 0 to 1 is 1. The last thing you have to talk about is horizontal shift, but you don't get that until you start coming up with what equations you want to use. So already I've drawn one for you starting here, right? Sine starts on the equation of axis on the y-axis, which that's on the y-axis. However, this one starts out by going down, right, as opposed to going up. So that's just simply a negative sine x. There's one right off the bat. So f of x equals negative sine x. Another one. And I'm going to move it around between sine and cosine. Cosine normally starts at a max or a min. There's a max right there. Normally it's on the y-axis. I've shifted left pi over 2. So another function could be f of x equals cos x. Now since I shifted left, plus pi over 2. Let's do another one, right? We need 4. If I go here, oops, don't want white. If I go here, it's like cos, but it's starting at a minimum, and it goes up, so I know it's negative. And I've shifted right pi over 2. So another possible function, f of x equals negative cos, and then since I shifted right pi over 2 would be x minus pi over 2. And one more, let's say we start here. That's typically where sine starts, right? Equation of axis, and I'm going up, so it's positive. And I've shifted right by pi. So a fourth function, and again, there are an infinite number of functions for this, positive sign, and I've shifted right pi, so it would be x minus pi. So there's 4 possible functions. That's what you would have done last unit. Those are equivalent functions. So if you were to take any value of x, let's just say x equals pi over 3. I challenge you, make sure your calculator's in radian mode. Put pi over 3 in for all of the x's, and all 4 of those functions should be the exact same value, meaning they're equivalent. There's a relationship that exists. So I'm going to quickly go over some of the things that you're going to see on your formula sheet. So recall even and odd functions. The ones you see in front of you are odd. And if we go back to the first unit, for a function to be odd, that means f of negative x has to equal negative f of x, which means for sine of negative x equals negative sine x. And for tan, the same thing, because that's a tan graph, tan negative x equals negative tan x. Those are equivalent functions, okay? And because they show odd symmetry, and really they're your first 2 identities you've seen. For an even function, that would be cosine. It shows even symmetry, which we call from unit 1. That means f of negative x equals f of x. So for cosine, that means cos of negative x equals cos x. These are already on your formula sheet, or they should be, I believe. If they're not, you can add them, but we're just quickly going over why and kind of going through these very quickly. So equivalent expressions. Using the following special triangle, determine the exact values of the 6 trig ratios for each angle. Identify any relationships you notice. So that's a special triangle. You don't actually have to do that. We'd spend a lot longer talking about this and experimenting and investigating and having a big discussion about this. I'm going to cut to the chase, and I'm going to just, so again, you don't have to really do it. I'm telling you to do, don't find the 6 trig ratios unless you really want to. I'm just going to start here with sine pi over 6. What is sine pi over 6? Well, opposite over hypotenuse, right? That would be 1/2. Cos, this time pi over 3. That's adjacent over hypotenuse, which again is 1/2. These are the same. They're equivalent. That must mean that there is some relationship that exists. That relationship is, even though it's not written in there, what angle does that make? 90. And what is that? Pi over 2. And if you were to use your calculator, what's pi over 2 minus pi over 6? Or in other words, what's 1/2 minus 1/6? A third. So there's definitely a relationship. Now I've just done 2 of them. There's a bunch of them that all exist, again, that we would go over, but we're just going to stick with this. And then we're going to come up with our cofunction identities. So cofunction identities. We're going to start with quadrant 1. So again, 90 is pi over 2. And if I call that theta, it doesn't matter which one you call theta, but let's say you call that theta, how do you get the other angle? Well, you would do 90 minus that angle. So this angle right here is technically pi over 2 minus theta. And if theta is our reference angle, this is opposite, right? And this would be adjacent, and this would be hypotenuse. So let's start with sine theta. Sine theta, opposite over hypotenuse, right? That would be the exact same thing as adjacent over hypotenuse, but from the perspective of pi over 2 minus theta. So sine theta equals the exact same thing as cos pi over 2 minus theta. We just proved that very simply by doing sine pi over 6 equals the same thing as cos 1/3. Cos theta, adjacent over hypotenuse, is the same thing as if our point of reference, so instead of using theta, adjacent over hypotenuse as our point of reference, if we use the other angle, pi over 2 minus theta, that would be the same thing as opposite over hypotenuse, which would be sine of that. Now tan theta is opposite over adjacent. If I go from the point of view of pi over 2 minus theta, that would be adjacent opposite over adjacent, which is the opposite of tan, the reciprocal of tan, which would be cotangent. Now, like I said, I'm glossing over these pretty quickly. You already have these written down on your formula sheet, or at least you should. If you don't understand completely, it's not that big a deal. You just need to know them, be able to reference them, and know how to use them, which we're eventually going to get to. So those are your cofunction identities. Equivalent identities. So we're going to start with quadrant 2. So we have a triangle there. I'm going to get rid of that alpha symbol and just make it a theta, because that's what we're sticking with. It's the unit circle, radius 1, you have x, you have y. We're going to go into quadrant 2. So we're going to draw that same triangle. And that related acute angle is theta, so that means that's also theta. And if I go to quadrant 2, that means I'm starting here and going all the way around. How do I get that angle? That would be, so remember this right here is theta. That's, or sorry, not theta, pi, which is 180 degrees, right? So if I wanted to get that angle in standard position, right, from 0 to the terminal arm, that would be, I would take pi and subtract theta. So that's pi minus theta. So that's going to help us, and again, this is x and y, and that's 1. So this is going to help us come up with some equivalent identities, which we've already done from a graph. We haven't done it in the Cartesian plane, but the Cartesian plane is just another representation of an x and y axis. One thing you do have to remember when you're doing this before we actually go any further, CAST rule, right? C, A, S, T. So where you see the C, only cos is positive. Where you see the A, all are positive. Where you see the S, quadrant 2, only sine is positive. And then down at the bottom left, you see the T, only tan is positive. So if I want to know sine of pi minus theta, you use the related acute angle in the red triangle I drew in quadrant 2, right? They're equivalent. You've already done that in grade 11 with degrees, and we've already done it in the last unit with radians. It is equal to the exact same thing as sine theta. And since sine is positive in quadrant 2, that's why that's positive. If I wanted to find the cosine of that angle in standard position. You're still going to use the related acute angle theta, but since sine is the only one positive, it's equal to negative cos theta. Same idea for tan. Only sine is positive, so using the related acute angle, it would be equal to negative tan theta. And you can always double check your work. So if you want theta, now keep in mind you have to make theta an acute angle, but if you wanted theta to be, I don't know, pi over 5, if you type in sine pi minus pi over 5 in brackets, hit equals, and then type in sine pi over 5, you should get the exact same answer. And same thing for cos and for tan. Moving along to quadrant 3. And again, you should already have all of these on your formula sheet. If you don't, or you just want to recopy them, you are more than welcome to. We're just quickly going through and kind of explaining how these work. So there's theta, related acute angle, right there, same thing. And I want to know that angle in standard position. So again, x, y, unit circle, and don't forget that's pi, 180 degrees. And cast rule, C-A-S-T. So that angle in standard position, right, going all the way to the terminal arm in quadrant 3, would be pi plus theta. Only tan is positive in that quadrant, so it follows that if I wanted to calculate sine of that angle in standard position, it would be equal to the negative sine of that related acute angle. Cos of that angle in standard position would be equal to the negative cos of the related acute angle. And then tan would be equal to the positive version because only tan is positive down there. So tan pi plus theta equals the exact same thing as the positive tan theta. And again, you can pick any acute angle you want for theta, plug it into your calculator, you should get left side equals right side. Lastly, quadrant 4. So down here, related acute angle theta, theta, y, 1, and I want the angle in standard position, so all the way to there. Don't forget, that's pi, and right here is 2 pi, right? On top is 0, on the bottom is 2 pi. Cast, C-A-S-T. That angle in standard position, how could you calculate that? Well, we would do 2 pi minus theta would give me that angle in standard position. And by now you might be getting the drill, and if not, that's okay. You just have to know how to use these. Sine 2 pi minus theta, only cos is positive, right? So this would be negative sine theta. Cos of that standard angle would be positive cos theta. And then tan of 2 pi minus theta would be equal to negative tan of theta, which is the related acute angle. So let's get to some examples. State an equivalent expression using today's identities. So you have to use what we've learned today. You can't just kind of come up with them out of thin air. First thing you have to realize, that angle, pi over 6, that's acute. It's in quadrant 1. So first key, that's in quadrant 1. Which means that we can use our cofunction identities from quadrant 1. If you look at it, sine theta equals cos pi over 2 minus theta. In this case, what's your theta? Your theta is pi over 6. So sine pi over 6 equals cos. Again, theta was pi over 6, so it's pi over 6 on this side as well. Using your calculator, 1/2 minus a sixth equals a third. So this is the same thing as cos pi over 3. So there is an equivalent expression using today's identities. Tan 3 pi over 8. Depending on your fraction work, you know that's in quadrant 1. If your fraction work isn't very good, think about it in terms of degrees first. So change pi to 180, do 3 times 180 divided by 8. You'll have an acute angle in quadrant 1. Looking at our cofunction identities for quadrant 1, tan theta equals cotangent pi over 2 minus theta. In this case, my theta is 3 pi over 8, so tan 3 pi over 8 equals cotangent pi over 2 minus 3 pi over 8. Doing some fancy fraction work, what is 1/2 minus 3/8? It is 1/8, so in this case, cotangent pi over 8. Again, you can always check your answers to these. So yes, for your virtual test, you need to show your work, but you have the benefit always of checking your answers. Type that into your calculator in radian mode, and you should get the exact same answer, right? Okay, so let's get out of quadrant 1. So we want an equivalent expression using today's identities. 13 pi over 12. What quadrant is that in? 13 pi over 12. If you're not sure, I like to go off of the pi line. So like 12 pi over 12 would be the pi line. That's 180. That's 1/12 over that, or pi over 12 over that. So you know you're in quadrant 3. You could also take a look at that unit circle diagram I gave you in some of the lessons last unit. Or you could go back to degrees if that's your comfort zone. 13 times 180 divided by 12, figure out what quadrant it is in. But it is in fact in quadrant 3. So we have to use our quadrant 3 cofunction equivalent, equivalent expressions. And since this is cos, so pi plus theta equals negative cos theta. Now, one thing you have to remember when you're doing this, when you're not working in quadrant 1, theta is always the related acute angle. 13 pi over 12 is not the related acute angle. That is the angle in standard position. That's giving you the pi plus theta, right? And if you should know that because 13 times 180 divided by 12 is clearly not an acute angle. It is not between 0 and 90 degrees. So what you have to realize is that they gave you the angle in standard position. This is the pi plus theta angle. So really all you're doing is solving an equation, right? We know that pi plus theta equals 13 pi over 12. And I want to solve for theta. Bring over the pi. 13 pi over 12 minus pi. 13 over 12 minus 1, that just gives you pi over 12. So you've just calculated theta. So what this means is that cos 13 pi over 12 is equal to negative cos pi over 12. Again, you can check that by typing on your calculator in radian mode. The next one, D, cos. 11 pi over 6. However you figure out what quadrant it is, completely up to you. It is in quadrant 4. So that means we're going to use the equivalent cosine expression for quadrant 4, which is cos 2 pi minus theta equals cos theta. Again, that is not an acute angle. That is not theta. That is not the related acute angle theta. That is the angle in standard position. So they've given you this. So just like the last example, see 2 pi minus theta. They gave that to us. It's this, 11 pi over 6. To solve for theta, okay, I could, to make it a little bit less complicated, I don't want a negative theta. Bring this over and then bring the negative theta over, becomes positive. So 2 pi minus 11 pi over 6 equals theta. 2 minus 11 sixths gives you 1/6. So pi over 6 equals theta. That tells us that cos 11 pi over 6 is equal to cos pi over 6. And again, you can double check your work on this. That's it for your first trig identity lesson. There's your work. As always, check D2L to make sure that I haven't changed any of the questions. Before signing off, I just want to say you are not required to, but you could be doing yourself a little bit of a favor and giving yourself more time to review for the test next Wednesday afternoon. If you have like a free hour, hour and a half, which I'm sure a lot of you will, but you don't have to. If you feel so inclined, it's your choice. But if you have an extra hour and a half or something like that this weekend, I would say maybe try your hand at the next lesson, which would just mean you'll have less to do next Tuesday and Wednesday morning before your test on Wednesday afternoon. Again, you don't have to, it's your choice. I'm just putting it out there for you. That's it. Thanks for listening. Have a fantastic and safe long weekend.